Bearcats, this is Unit 4 pretest, Day 2. Oh, I didn't write that in there. This is Day 2. Day 1 was the multiple choice that you did on Blackboard, and these are the video notes for this. So, we're going to first start with number 1, which is find the zeros of the function by factoring. And so we're going to factor, we're going to set it equal to 0, and I'd like to not have a negative in front of my x squared, so I'm going to move everything to the right, so I can clear out that negative. So it'd be a positive x squared. If I move the 37 over, it becomes a positive 37x. I didn't move the 70. It stays at positive 70. And now all of that would be equal to 0. All right, so let's go ahead and factor. No coefficients, so we don't need to slip and divide. We're just going to go ahead and set up shop. And we have x and x. And we need numbers that multiply to 70, but that add to 37. And I believe we would get 2 times 35. 2 times 35 is 70. 2 plus 35 is 37. And they would both be positive. So our zeros then would be x, one of the x values, the zeros or the solutions or the roots would be -2 and -35. There's the first one. All right, we're going to continue to solve by factoring, and again we're going to set it equal to 0. So again I'm going to move everything to the right so that my squared term coefficient is positive. So I would end up having here, it would be 2x squared. I would have to move the 20 over to become a -20x, and I'd move the 50 over, which would become positive 50, and that equals 0. Now in this particular case, and you always want to look for GCF, greatest common factor. In this case, if you're paying attention, you can factor out a 2 right from the beginning. So let's do that. We take out a 2 and we get x squared minus 10x plus 25 equals 0. And now at this point we can actually factor everything out. So we're going to keep out the 2. That's a factor. Since there's no x, we're not going to get an intercept from that. But this will have a factor, and we'll have x and x. Multiply to 25, add to -10. How about a -5 and a -5? -5 times -5 is positive 25. -5 plus -5 is -10. Now look at this, is interesting. This time we have an x value of 5, and this would also be an x value of 5. So the only x value, the only x-intercept for this quadratic would be at 5. In a graph, just so you remember, then at 5, that graph would look something like that. It would just have one x-intercept. Above here, we would have had a graph that had an x-intercept at -35 and -2, and our graph would have looked something like that, and that's where it would have crossed the x-axis. All right, go Bearcats. All right, next we're going to have solve by extracting the square roots, and sometimes that verbiage, those words confuse you. We're really still solving for x. In all of these problems we're solving for x. We're just going to extract a square root, or we're going to take a square root in this problem. That's how we're going to clear out the square. So we take a square root. Now, we know that when we take a square root of a value that wasn't there, that square root was not there originally in the problem, then we became an artist, and we have to sign our artwork plus or minus. So this square root cancels the square. You're going to be left with x minus 3 equals the square root of 81. That's going to be plus or minus, and the square root of 81 is 9. And then we're going to have to add the 3 and sneak it in over here. Here's how I like to write that. I think that's going to be a positive 3 plus 9 and a positive 3 minus 9. And so 3 plus 9 is 12, and 3 minus 9 is -6. So my x-intercepts, my solutions, my roots are 12 and -6. Go Bearcats. Pause and think through this if you need a little more time. All right, here we go with number 4. Again, we're still extracting square roots, so we're going to take our square root and take our square root. Now that's going to cancel, and we're going to end up with 2x minus 4 equals positive or negative square roots of 72. All right, we have a decision to make here. We can either simplify the square root of 72 right now, or go ahead and finish everything up first. I'm going to go ahead and finish and then simplify, but it's really up to you what you prefer to do. I'm going to say at this point I need to add the 4 and put it in front. So now I have 2x equals positive 4 plus or minus the square root of 72. And then I'm going to divide by 2, divide by 2. cancel this out, and right now I have x equals 4 plus or minus the square root of 72 over 2. And you would get most of your credit for that. I do want to see if you can go ahead and simplify the square root of 72. We're going to do that by our little prime factors that we've worked on. So you take 72, you could divide by 2 and get 36. Divide by 2 and get 18. Divide by 2 and get 9. Divide by, can't divide by 2, but 3 would be a prime number and get 3. Now look what happened here. Remember, we're going to take out pairs. So we take out a pair of 2s and we take out a pair of 3s. That 2 doesn't have a partner, so it's going to stay home. And we have a 2 on the outside and a 3 on the outside. Multiply those together and get 6. So you'll have 6 square roots of 2. So now I'm rewriting that x is equal to 4 plus or minus. I just simplified the square root of 72 to 6 square roots of 2 all over 2. And now we're going to go ahead and reduce this a little bit further. 2 goes into 2 once, 2 goes into 4 twice, and 2 goes into 6 3 times. So we have x equals 2 plus or minus 3 square roots of 2. That would be your final and full answer. This right here would get you most of your points. So focus on getting to this part first, go Bearcats, and then getting your full amount of points by being able to reduce. But don't miss out your major amount of points by trying to reduce first. That's why I was saying that. All right, go Bearcats. All right, in this section, we're asked to solve by completing the square. Please understand that on your test, you're going to be asked to solve by each of these methods. The format is very similar to both of the pre-tests that you've had. So when it asks you for a particular method, you really have to use that method. All right, so we're going to solve by completing the square. I'm going to just start from the beginning and set it equal to 0 and get everything in the right order. So I'm going to move this 2x over, and I'm going to go ahead and move the 8 over, although you could skip the 8 part if you understand this well enough. But I'm going to go ahead and start here and go x squared. I'd have the 2x move over be positive 2x. The 8 would move over be a negative 8, and that would equal 0. All right. Yes, I understand we could factor this, but we're not going to factor. We're going to actually go ahead and try to solve it by completing the square. When we complete the square, we're going to take our constant and move it to the right. That's why I said you probably could have skipped the 8 part. So you'd have x squared plus 2x equals negative, it's now going to be positive 8. So we'll make that 8, positive 8. All right, now we're going to do x squared plus 2x plus blank. And we can do that because there's no coefficient in front of the x squared equals 8 plus blank. We're going to set up to complete the square. When you complete a square, it should look very similar to extracting the square root part, how those questions start out. You're trying to get to vertex form or standard form, and that's what you're trying to look like. So if you set it up, then you'll kind of know where you're headed. Remember, we bring down the x, the square's on the outside. We bring down the positive if it's positive. If that were negative, this would be subtraction. Half of the middle term, so half of 2 is 1. 1 squared is 1, and 1 goes in each of the blanks. All right, 8 plus 1 is 9. And now you're right back to where you were. I'm going to make a comment here because I think this is so important. Please understand, if we were graphing, we're not on this problem, but if we were graphing, and you will, this is why completing the square is important. We would move the 9 back over, and you would have x plus 1 squared minus 9 equals y, or whatever. Now, this is your vertex form. Remember, the transformation here would be negative 1. You would go to the left 1 and down 9. That would be your vertex point. Keep that in mind. We're going to talk about that over and over when we graph. So make sure you're really good to go. Remember, I said I believe on graphing it's better to complete the square. I believe on applications it's better to do negative b over 2a. Keep that straight for yourself. All right. Back to this problem, though. We want to solve for x. So we're going to extract the square root by square rooting. We get x plus 1 equals positive or negative. We were the artist. Square root of 9 is 3. And then we're going to subtract this 1 and put it in front. Remember how I like to do this. We have that negative 1 plus 3. And we have that negative 1 minus 3. And negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. So our x values are 2 and negative 4. And go Bearcats. All right, we have another completing the square. Again, let's move everything back to the same side. So if I do that, I would get x squared. I'd move the negative 16 to become positive 16x. I'd move the positive a to become a negative a equals 0. All right, starting with the constant, I move it back. So I would have x squared plus 16x. Remember, no coefficient in front. I'm going to go and say plus blank. Equals, I move the 8 over, it becomes a positive 8 plus blank. Set up shop, so it looks like you are getting to transformation or vertex form or standard form, or very similar to the way the equations in extracting the square roots look. Whichever of those thought processes helps you remember what to do, think of that. All right, so we're going to bring down the x. Again, this is plus. Now, half of 16 is 8, and 8 squared is 64. And so 64 goes in that blank, and 64 goes in this blank. I just noticed a mistake on my problem. All right. Equals. 64 and 8, I believe, is going to be 72. And now we're going to go back to simplifying our radical in a minute. So we're going to square root, and square root, we have x plus 8 equals, plus or minus, the square root is 72. And we're going to subtract the 8 in front. Now, be really careful. I think we've seen 72 before, but we're going to practice again. Again, if we were graphing, you would have moved the 72 over, and you would have had gone to the left 8, so that's negative 8, and then you would have had negative 72 as your vertex. Remember that when we start graphing. All right, on this one then, you're going to have x equals negative 8 plus or minus the square root of 72. Let's go ahead and reduce our radical. That will get you the majority of your points right there. So when I reduce my radical, 72, I simplify. Divide by 2 is 36. Divide by 2 is 18. Divide by 2 is 9. And then remember, divide by 3 is 3. A pair of 3s and a pair of 2. 2 times 3 is 6. That 2 right there stays home. And so we have x equals negative 8 plus or minus 6 square roots of 2. That would get you full points, but this would get you the majority. So make sure you focus on getting there and then strive to get this last little bit. All right, way to go, Bearcats. All right, in this equation we have f of x equals x squared plus 8x plus 5. Again, I'm going to just say it's equal to 0 since we're solving. And when we think about that, makes sense. We're trying to find the x-intercepts. The x-intercepts are when the y value is 0. That's why we set it equal to 0. And this is going to ask us to use the quadratic formula. So I'm going to go ahead and write it down once for you. It's negative b plus or minus the square root b squared minus 4ac all over 2a. And then I'm going to tell you, I think it's very important to list your a, b, and c. Your a in this occasion is 1. B is 8, and C is 5. Please list them out. I want to see the substitution into the formula. The way I'm doing this process right now is what I should see on your test. That way I can grade you for partial credit. I can know where you went wrong if you do, and you will be more successful if you do it this way. So, negative B would be a negative 8 plus or minus the square root of. B squared, that is 8 squared. I'm going to go and square it before I put it in there. 64. Every time I square a number, it's positive. Minus 4 times a, which is 1, times c, which is 5. And that's going to be all over 2 times a, which is 1. Then I'm going to simplify negative 8 plus or minus the square root. And remember, that number underneath that we're going to find is called the discriminant. That helps us determine how many solutions we have. And 2 times 1 is 2. Now, this is 64 minus 4 times 1 times 5 is 20. 64 minus 20 is going to be 44. Be really careful in that step. That is where usually you make the biggest mistakes, is going from here to here. Be really, really careful. Keep your eyes, Bearcats, wide open. All right, let's keep going. Now, this will get you most of your points right here, this answer right here. I want to see, though, that you can simplify the radical to get your full points. So, 44 divided by 2 is 22. Divided by 2 is 11. 11 is a prime number. I can take out the 2 because I have a pair of them, and I have 2 square roots of 11 to replace the square root of 44 with. Let's see where we are. Negative 8 plus or minus 2 square roots of 11 over 2. Now simplify the last step. 2 goes into 2 once. 2 goes into 2 once. 2 goes into negative 8, negative 4 times. So this would give me negative 4 plus or minus 1 square roots of 11, or just you can write it as the square root of 11. And that, my friends and Bearcats Nation, would be the final answer. Go Bearcats! All right, still using the quadratic formula. We'll write it down one more time. Negative b plus or minus square root b squared minus 4ac all over 2a. You should write that down every time, and I think you'll have more success. Now, this isn't set to 0, and we need to do that. We need to move the 12 back over. So we're going to go x squared plus 15x minus 12 equals 0. Our a value is 1, our b value is 15, and our c value is negative 12. Let's see where that gets us. Let's plug into our formula. Negative b, that would be a negative 15 plus or minus the square root of 15 squared. All right, if you have a blue calculator, 15 squared is 15 times 15, which is 225. 225. Minus 4 times a, which is 1, times c, which is negative 12, all over 2a, which is 1. Now, I want to show you something really quick. When you have subtraction and there's a 1 negative over here, please realize that's like a negative 4 times a negative 12. This is all going to become positive. You're going to be adding. So you may want to right now go plus a positive so that you don't make a mistake. That's one of the big mistakes made. All right, let's keep going. Negative 15 plus or minus the square root of. We're going to figure out what the discriminant is, all over 2. So this is 225 plus. All right, so 4 times 12 is actually 48. So plus 48. 225 plus 48 is 273. I believe 273 is not reducible. If it's a big number like that, you might just, if it's not a perfect square, you might could leave it, and we'll talk about that. If you have time, then try to reduce it, and that, Bearcats, would be your answer. Go Bearcats. All right, this next one is where you have to write the standard form of the equation. Well, first of all, when you see that word, standard form of the equation, you have to know what that is. So please make sure, write this down as many times until you just have it in your memory bank, just like you have the quadratic formula. If you can remember them well enough for yourself, great. If you have trouble, at least remember it well enough to get your test and write it on the top of your test. So y, standard form, y equals a parentheses x minus h squared plus k. You've got to know that form of the equation. All right, we're given a vertex at 7, 6. That is our h and our k. Make sure you know that the vertex is the h and the k. We're also given a point on the parabola at 5, 5, and that's your x and your y. All right, this is kind of a two-step problem. We're going to solve for a, and then we're going to go back and write the equation. So pay attention to the process. Not the number so much, but the process. All right, plug in everything because you have a y, an x, an h, and a k, and then you can solve for a. Y would be 5 equals a, we don't know. X would be 5 minus h was 7. Square it. Plus k is 6. All right, let's solve for a. First of all, parentheses. 5 minus 7 is negative 2. Negative 2 squared is 4. So that is 5 equals 4 times a, 4a, plus 6. If you don't get that part right there, pause and go back and make sure you understand that. Now we're just solving. So you're going to say minus 6, subtract 6. So we have 4a equals 5 minus 6. That's a negative 1. Divide by 4, and a, in this case, is negative 1/4. A is negative 1/4. 1/4. All right, now we're going to go back in and we're going to put the A in. I'm going to change pen color so you see this. We're going to put the A in, we're going to put the H in, and we're going to put the K in. And that is the equation we're looking for with values where A, H, and K are. Leave the X and Y as variables. All right, so we're going to have Y equals A, which is -1/4, times X minus H, which is 7 squared, plus K, which is 6. That, Bearcats, is your answer. All right, we have another one to practice, putting it in standard form. Again, you must know that equation. They give us the vertex, -1, 2, which is your H and your K, and then they give us a point at 1, 6, which is your X and your Y. First we solve for A, then we plug it all back in. All right, so we're going to say Y, which is 6, equals A. We're going to figure that out. X, which is, which is 1. Minus H. So minus H, and H is -1, so that's going to be plum and plus a positive. Watch that. And we're going to square all that. And then plus K, and K is 2. So 1 plus 1 is 2. 2 squared is 4. So 4 times A. So we have 6 equals 4A plus 2. We're going to subtract 2. So we get 4A equals 6 minus 2 is 4. Ah, look, divide by 4 on both sides, and A is 1. Go over and write your equation. That's part 1, but the equation and what you really want is the equation. So Y equals our A value of 1 times X. Remember, we're going to go ahead and put in our H. So minus a -1, which is plus a 1. Watch that. Squared plus K, which is 2. That would be our final answer. Go Bearcats. All right, next we're going to be talking about graphing, and you're going to have to actually graph these, I believe, on your test, and we're trying to identify the vertex, the axis of symmetry, the x-intercepts, and the y-intercepts. The first one we're looking at is in vertex form already. That's a good thing, but you got to be careful about some other things. The good thing is this is the same as saying x minus 3 squared minus 5 equals y. All right, and this is like saying transformations. This is x minus 3. We would go to the right 3, and we would go down 5. And our vertex is at 3, -5. So our vertex is at 3, -5. If you think about sketching, it will really help you. Our vertex is at 1, 2, 3, -5. So our vertex is down here. So we know our graph goes up like this. Axis of symmetry runs right through here. What was this? This was at 3. It's always the x value. So your axis of symmetry is x equals 3. Notice that connection right there. All right. We need to keep using this formula to find our x-intercept. So we have x minus 3 squared minus 5. Set it equal to 0 to find the x-intercepts. That's when y is 0. We would move the 5 over. We would have x minus 3 squared equals +5. We would square root. We were an artist. X minus 3 equals positive or negative square roots of 5. Plus 3. Stick it in front. So our x-intercepts are 3 plus or minus the square root of 5. So it's at 3 plus the square root of 5, 3 minus the square root of 5. That would get us our x-intercepts. That's very similar to when we do conic sections later on in the year. The last one. In this form, all of this is pretty easy. The y-intercept is actually the hardest to find. The y-intercept is when the x value is 0. So let's look at how we find the y-intercept. We have to be really careful in this case. Please do not automatically look and tell me it's -5, because it's not. So we're going to put in a 0 for x. So 0 minus 3 squared minus 5. All right, 0 minus 3 is -3. -3 squared is 9 minus 5. 9 minus 5 is 4. Your y-intercept is at 4. So it would be at 0, 4. All right, Go Bearcats. Let's move on and do a few more of these. All right, for number 12, we're also asked to find the vertex, the axis of symmetry, the x-intercept, and the y-intercept. And remember what I told you, except for the application problems, I would use completing the square because it will help you find the axis of symmetry, the vertex, and your x-intercepts, all using that same process. Although it gets a little tedious, and in this case it's going to because we're going to have a few fractions. So hold on and try to pay attention here. All right, the first thing we're going to do is do the y-intercept, because when you're in this form, remember the y-intercept is when x is 0. If I make that 0 and that 0, all that goes out and you're left with negative 24. So get all the parts that you can. The y-intercept will be negative 24. The rest of this is going to come from completing the square. All right, when we complete the square, we're going to move the constant over to the right. So we're going to get x squared plus 5x equals positive 24. And remember, we're going to put a plus blank and a plus blank in there. We can't do that if there's a coefficient. We have to take care of that first. But in this case, there is no coefficient. We'll see in a little bit if I decide to give you one with or without. I don't think I did though. All right, so we're going to complete the square. You're going to set up your little thing to complete the square. This is where you're going to be really careful. X goes down, positive or plus, this is plus. Half of 5, that's just that value over 2. Now you're going to square it before you put it back in the blank. So 5 squared is 25 and 2 squared is 4. And you're going to put 25 over 4 here. All right, now this is where you have to be a little bit careful. I need to change 24 to fourths. If you have a blue calculator, you can do it in there, but be really careful. I'm going to do it the old-fashioned way. 4 times 24 will be, I believe, 96. So 4 times 24 is 96. So this really is 96 over 4 plus 25 over 4. So I have x plus 5/2 squared equals. Well, 96 and 25 is 121 over 4. All right, you should start to feel good about now because both of those are perfect square values. That means something's going to come out easier for us in just a minute. All right, so before, though, I go on to finish solving, I'm going to give you my vertex. Remember, we would move this over. And if we did, it would have said x plus 5 over 2 squared minus 121 over 4. And our vertex would have gone transformations. This would say plus, so to the left, so negative 5/2. And we would have gone down negative 121 over 4. And that's your vertex point. I'm going to go ahead and write it over here. So negative 5/2. Negative 121 over 4. It's like a big puzzle. Imagine you found that on your graph. And sometimes sketching a graph will help make sure that you're not getting way off base. All right, now keep going back to this place right here and finish solving. If I wanted to finish solving, I would square root. Watch this little trick. Square root the top, square root the bottom separately. We were an artist. You're going to have to put plus or minus. So I have x plus 5/2 equals plus or minus. The square root of 121 is 11. And the square root of 4 is 2. How nice is that? All right, so we're going to subtract 5/2 and sneak it in front. And you can simply tell me then that it's negative 5/2 plus or minus 11/2. And I'll let you just leave it like that if it were a number that way. So your x-intercepts are negative 5/2 plus or minus 11/2. And that's two answers because it would be negative 5/2 plus 11/2, negative 5/2 minus 11/2. Oh, axis, that's the easy one. Remember, it's always the x value. X equals negative 5/2. All right, that was a little intense. Take a little break if you need to and come back, but make sure you understand. Keep practicing these. All right, we're back to standard form. We're given standard form and we're finding the vertex, the axis of symmetry, the x-intercept, and the y-intercepts. All right, in this case, the vertex is kind of staring us in the face. Remember, if we were looking at transformations, if our original graph, parent graph, looked like this, because it would be a parabola, and we would take that 0, 0 point, then we would move to the left 7 or negative 7, and we would move up 4 or plus 4. So I'm going to put a comma there. Negative 7, 4 would be our vertex. Think about that. You can only 0, 0. You can't reflect or stretch or compress. You're only moving it left and right and up and down. All right, remember that the axis is always the x value. X equals negative 7. All right, now remember, take a look here. Our new graph would be at negative 7, 4. That's our vertex. This negative in the front means it's going to be turning downward. Its axis of symmetry, of course, is at negative 7. It's going to be going down like this. So we are going to have x-intercepts, and we're going to have a y-intercept way down here somewhere. So let's take a look, and first let's go ahead and finish using this problem in this form, solve for x to find our x-intercepts. So I'm going to go down here and just rewrite it to give myself a little more room. I'm going to set it equal to 0. So I'm going to move the 4 over, and I have negative 1/7 times x plus 7 squared equals negative 4. Then I'm going to multiply by the reciprocal of negative 7 over 1, or negative 7. So I'll multiply by negative 7 over here. That crosses this out, and I have x plus 7 squared equals negative times negative would be a positive 28. Positive 28. The next thing I'm going to do is I'm going to square root, and I have x plus 7 equals, I was an artist, plus or minus the square root of 28. I subtract the 7 and put it in front, so minus 7. So I have negative 7 plus or minus the square root of 28. That would probably get you most of the points, maybe 1 point off. I would like to see you reduce your square root. So 28 divided by 2 is 14. Divided by 2 is 7. So take out a pair. That 2 comes out. 7 would stay home. And this would be negative 7 plus or minus 2 square roots of 7. And that's what I would like to see. That would get your full points for your x-intercepts. So negative 7 plus or minus 2 square roots of 7. Y-intercept. Remember, the y-intercept is the place we have to be a little careful. We have to actually plug in a 0 for the x. So let's do that. I'm going to erase this right here and give myself a little more room. So let's just plug in a 0. So we have negative 1/7 times 0 plus 7 squared plus 4. All right. So 0 plus 7 is 7. 7 squared is 49. So we have negative 1/7 times 49 plus 4. Well, negative 1/7 times 49 is going to give us negative 7. So negative 7 plus 4 would give us negative 3. Our y-intercept would be negative 3, and that makes sense. Remember, I said it would be down here. So it is 0, negative 3 as my y-intercept. All right, I think 3 more problems to go. All right, again, vertex, axis of symmetry, x-intercept, and y-intercept, and this time we're given general form. We're going to put it in standard form by completing the square. All right, before I do that, though, I'm going to do the y-intercept because that's the easy one when it's in this form, 0. A 0 here and a 0 here, make it all go away, and we're left with 12. So we know our y-intercept is at 12. I'm just going to use a little sketch over here to kind of keep me on track. So my y-intercept's at 0, 12. That's my y-intercept. All right, let's complete the square to find the vertex. So let's do that. There's a couple things we could do to find the vertex and the axis of symmetry. I'm going to go ahead and leave the negative in there, though, because I think it's important that you understand that. So think of that as a negative 1. A negative 1. I'm going to move the 12 over, and I have negative 1x squared plus 4x equals negative 12. All right, I have to factor out the negative 1. And I know there's a simpler way we could do this, but this also explains when you have any coefficient the process, and I think that's important. So I'm going to take out the negative 1, and I would have x squared minus 4x plus blank equals negative 12 plus blank. And that blank would have to be multiplied by the negative 1. Okay, I'm going to go kind of slow and let you think about this. Pause if you need to think more. Keep the negative 1, don't let it go. Complete the square. So x, this is subtraction, this is subtraction. Half of 4 is 2. 2 squared is 4, that's what goes in the blank. All right, and in this case, here's what would happen. I would have negative 12 plus a negative 4. That would be a negative 16. If I want to find the vertex, I move the 16 to the other side. I have negative 1, x minus 2 squared, positive 16. My vertex would be, I would transformation, it's x minus 2, I'd go to the right 2, positive 2, and I'd go up 16, positive 16. My vertex is at 2, 16. So let's think about that. At 2, 16, way up here. So my graph is negative, so I know my graph is going to turn down. That makes sense. It's going to go through the y-intercept. All right, next, my axis of symmetry always comes from the x value of my vertex. So don't forget that. X, remember, will equal 2. So now we're finding the x-intercept. So we're going back to this right here and finish solving. I'm going to write it again. Negative 1, x minus 2 squared equals negative 16. And we're going to solve for x to find our x-intercepts. I'm going to divide by negative 1. So I have x minus 2 squared equals positive 16. Making sense. Square root. X minus 2 equals plus or minus, I was an artist, square root of 16 is 4. Add this 2, sneak it in front. And remember how I like to do that. 2 plus 4, 2 minus 4. That's 6 and negative 2. That makes sense. This would be your negative 2, and this over here would be your 6. So my x-intercepts are at 6 and negative 2. Your teacher may want you to write those as ordered pairs. It'd be 6, 0 and negative 2, 0. You just have to know what she wants. For me, you can just write it like that. All right, go Bearcats. All right, we've got our applications. Remember, once we switch to applications, what are we going to do? We're going to think negative b over 2a, plug it back in if we need the y. We're going to think negative b over 2a, plug it in if we need the y, if we're doing applications. Make sure you really get that. This is when we switch gears a little. All right, this says it's about a rugby ball being punted, and this is the equation. And let's identify what it's saying. We know it's a negative, so you know your graph is going to turn downward. It's going to be a sad face parabola. We know that you're going to have, let's just draw this out and talk about what this says. It says x is the horizontal distance. So this is the horizontal distance, and that's your x value. And it says that the h of x, where x is the horizontal distance, where the ball is punted, and it is h is the height, sorry. So the h of x, the y value, is the height. So how high did the ball go? How far away from where he originally punted it did it go? Okay, the question here asks how far horizontally. Okay, is the ball from the kicker when it's at its highest point? Well, the highest point, we're talking about a max. And a maximum is a point where the parabola makes the turn, and it's going to have a value, an x and y value, okay? It's going to be a point right there. We want to know how far horizontally. Well, that would be the x part. We just want the x part. All you want is the x part in this case. So if all we want is the x part, then we can do x equals negative b over 2a. This is applications, remember. So again, this negative 1 over 64 is your a value, your 3/4 is your b value, and 3 would be your c value. Just identify those to make sure you're careful. So x equals negative b. That would be a negative 3/4. Okay, all over 2a, or negative b over 2a. This over part is like a big fraction bar, which means division. So I'm going to write it as old-fashioned division. 2 times a, and a is negative 1 over 64. So I get negative 3/4 divided by negative 2 over 64. I could reduce that to 1 over 32. Let's do that. Negative 1 over 32. I just reduced it. And instead of dividing by a fraction, I'm going to multiply by its reciprocal. So negative 3/4 times negative 32 over 1. Now, I don't have a calculator. I'm going to cross cancel. If you have a blue calculator, you could figure this out, but I think you should just do it without, because you're going to have to when you go off to college, all you seniors. So cross cancel. 4 goes into 32 8 times. Look at this. Negative 3 times negative 8 is a positive 24. And we were talking about horizontal distance in feet, so it's 24 feet away. So at the highest point, the ball would be, sorry about that. At the highest point, the ball would be 24 feet away. All right, last problem. Okay, this one gives you a profit statement. It says the Bearcat Manufacturing estimates that its profit in hundreds of dollars. Ooh, please read that and underline hundreds. Hundreds, that would mean 2 zeros. Hundreds of dollars. The profit is given by that statement. And it says where X is the number of units produced in thousands. Oh, units in thousands. So the units would have 3 zeros added to it. How many units? Oh, it sounds like we're going to want to know the units. All right, let's go ahead and see what we have here. It's a negative, so again, a parabola turning downward. Let's identify our axis. This says our profit, so P represents our Y value is our profit, and that's in hundreds. And our X value is our number of units, so this is units. It's our X value, and that's in thousands. All right, so let's just make note of all that. Now, it says how many units, okay, units are X, can be produced to obtain the maximum profit. Okay, again, a max. Max has an X and a Y value, and we want to know how many units, so we want to know the X. That's the easy one. So we're going to say X equals negative B over 2A. Now, if it asked you what the maximum profit was, then you would have to take your X value and plug it back in for the X's and find the profit. Okay, make sure you recognize that. Read carefully. All right, but this says negative B over 2A. So negative B, so A is negative 5, B is 50, C is negative 2. So negative B would be negative 50 over 2 times negative 5, negative 50 over negative 25. That's a positive 2. But that's not 2 units. Remember, units is in thousands, so that's going to be 2,000 units. Make sure you read carefully. Make sure you read carefully. All right, that's it. If we want to know what the maximum profit was, we would have to take our units and plug it back into our equation to find our profit. And once we did, then we would add, I think we would add the hundreds to make sure that it was in hundreds of dollars. All right, that's it. Have a great night. See you later, Bearcats.